but I start recording now. Ah. And then, yeah. So now I have these winsorizing. So I fixed here the the first percentile or those extreme value, the left side tail. And then I did the same thing. So now if I do this, and this is very easy way so that you can visualize. There are more sophisticated way you can visualize what is happening. So I did that. Now I will run proc means again. And now you will see the difference, minimum value. So this proc means now you see the minimum looks way better. And we did not lose any value because we winsorize. If you delete that, then it will shrink your value, right? But winsorizing is good. Now, almost done. Our data is now clean. So we will again, after winsorizing, I'll run the regression. Results didn't change much. After winsorizing, gender and age are not significant. So that means gender, age, those are very sensitive, maybe like depending on some observations, but these are we confident the relationships are pretty robust. The other financial, stock market and ROA variables. I will show you another thing, lag variable. Lag variable is very common. X or right hand side variables, you can use lag value, especially that is good for endogeneity and especially CEO compensation, or sometimes like your Y variable, mostly driven by not the current years, contemporary years, rather the past years, then it's good to take X or all lag variable. So you can just imagine, right, how it works. So usually we see how CEOs are working this year and whether they will get any bonus or any incentives. So based on this year's performance, we give the raise for next year. And that's why it makes sense. When we'll see compensation, let's see how those are related to past years or lagged or last year's performance. So now what I'll do, I'll show you how to create lag variables. So whenever you will create lag variables, make sure you sort the data by far by year. So I sorted. I know it's already sorted. Still, I did sort it. Now there are several ways to create lag. So I'm just showing you. I will create lag. So very simple way, lag. If you just take, I'm naming this lag variable as lag size. And then this is the function lag, just like log or any function ln, lag of size. So it will take the preceding row's value. But remember, if a farm A, that has like 10 years of observation, then farm B has another 10 years observation. The first year of farm B will take the last year of farm A's observation, right, as a lag. So what we need to do, if this is the first year of a farm, then we will have no lag, right? That means our data started from 2010 up to 2022. So 2011's lag will be 2010's data. 2012's lag will be 2011's data. So 2010 should not have any lag for all the farms. So that's why we did this. If first.gv key, that means this is the first farm within that sorted years, then do loop lag size is dot. Whenever you see do loop, then you have to close the loop, writing n. So I created lag. So you can do it. You can do, if you do loop, it's better to do one at a time. Otherwise, you need to close all the loops. So for each lag, I did it separately. I created lag size. I created lag stock return. You can do it. Just name the variables and take whose log will be. So there are also ways lead. SAS cannot do lead, but we reverse the data, ascending and descending, and then you can do lead variables, because sometimes we also need maybe Y variable, we need lead variables. So I created lag. Now I will check final data, how the lag look like. So these are the lag variables. And see, this is dot. That means this is the first year of the farm, right? This is the first year because this from here, you see my pointer, from here to here, we have a new farm. And this is probably 2020, and that's why we don't have any lag because we started with lag. So having lag is good, but we will lose all 2020's observations. That's fine, but I just want to check that lag does not alter any result. So this year we will see, yes, it's 2020, you see? So now I created lag. Now I will, instead of taking current year's X variables, I'm taking lag size, lag stock return, all these. Age and gender does not matter. Gender does not change that, and age and also like last year's age, this year's age. So this is since field specific, you can keep those. And the others, I'm now doing survey reg and I'm doing lag. So you see here lag result didn't change at all, but we can check very precisely. Oh no, age is now significant and negative after taking the lag. I don't know, maybe I could use lag, but I'll check one more thing. Predictability R square, p-value model, right? So when I take lag, R square is 47.53. When I do not take lag, R square is 49.40. What does that mean? That current years have more explanatory power? Maybe there might be some underlying theory, but it's good if you want to do just robustness check, or you could put all current year and lag year. When you report the result, make a separate column. Now, since 2020 all now have dots, so what I did, I just deleted all 2020. So I just deleted that. Now, from here, I will do my tables. And you can use this code for, if you use SAS, I will do my tables for the final table. And I'll show you what I did. You saw some Excel files, right? So when you do SAS, or no matter what you use, whatever the software you use, do not copy paste the software output on your final paper. So modify or convert it. Some software, for example, Stata, it comes out very nicely Excel table. You can directly copy paste on Word, but SAS does not. So when you will see SAS results, you need to copy and paste onto Excel. That's what I do. And then format the table Excel, and then I put it on Word. For example, now I will do the tables, actual tables. And if you want to count your farm, number of farms, this is how I do. So I'm just counting GV key and I'm checking a prop frequency table. So this is another way to see how many farms I have. So I have 22,940 observations because we dropped, because of lag thing, we dropped 2010's data. But we have 2,491 farms. And now we have about 12 years of data. That means not all farms are in every year. You can make a balanced panel, right? You can do that with coding, but that for when we do panel data, cross-sectional and time series all together, then it's fine. So if it's not balanced, that's fine. Now I'll show you the tables. And please, everyone, I know you are not writing the paper, you are not doing in-depth data work this semester, but next year you have to. That time, make sure you have these tables. And you pretty much read all the papers and I presented you. These are the standard tables. First, we show sample distribution. So I'm just showing it, sample distribution. by year, right? And then we will see how the table looks like. But it's not working. Proc sort. Proc sort by year. Let me sort it because you have to sort every time before you do proc fric. Yes, so this is my sample distribution. So what I do, I copy this one. I copy this table, and then you can just Control C, and then you can paste into an Excel sheet. I cannot switch to an Excel, but you can paste into Excel and then you can format it. Right. So then what we did industry distribution. Industry distribution. Oh, you have to uh, sort it first. Without sorting, you cannot get the correct distribution. Then I get industry distribution. So you can modify it. Agriculture, construction, you can write down all the industries if you want. You can show that first digit SIC. And these are percentage. You can put percentage. All this edit you can do on Excel. And then what we will do, sorry, why it stopped sharing. Let me share my screen got paused. Okay, so here what I'm doing now, you cannot minimize. Okay, so let me share my screen again. And then what we did, pretty standard table is this descriptive statistics, proc means function. And this is your descriptive statistics. But look at that, these descriptive statistics are all like normalized variables, log format, scale. Sometimes you may also make descriptive statistics like raw data, dollar value, right? Dollar value of sales, total assets, or total compensation, 1,000 or million. You can do that. Now, after descriptive statistics, I'll do correlation. Correlation, Pearson correlation. If you use proc core, then you will get Pearson correlation. And Pearson correlation, it's fine, widely accepted. Now you see the correlations. If you see any correlation is more than 0.7, 0.8. 0.7 is also fine. 0.8, 0.9 means those are highly correlated. And that can mislead your results. So if you see anything like 0.9, and then if you just alter all those variables, you will see the results are completely changed. That means you need to do either VIF test or you need to work on something to get rid of multicollinearity. And Tatiana was mentioning machine learning can help great. In that way, if you use machine learning, they deal with all those issues. But now we see our correlations are fine, except for size, which is very close to 7. And when I copy, we delete this part because it's the same thing. Two sides it's showing, but you can just show only one part. And this, you see this less than 0.001, those are significant. So all are significant. Those are kind of univariate results you are getting. And then you will do your regression. So just to show regression, we are just playing with one model, one simple hypothesis. So you can just, instead of just putting only one regression, the table may look so empty. So that's why you can do separate columns and you can run. First regression, I didn't control CEO characteristics. You already know that, the result, we saw that. And you can just check, results does not vary much, but I'm just showing that even after controlling CEO characteristics, after controlling standard errors, results are the same. And then we also did lag versions. We also did industry and year dummy. So these I would put as the final column, final model. Now what I'll show you, if you open the Excel files, there are some Excel files on Blackboard. Any questions so far? If you open the Excel files, you will see I downloaded, I just copied those, and I'll also show it to you. When you copy from SAS to Excel, one is like the raw results, right? When I copy it, you always, when you paste it on Excel, you right click and let me share the Excel thing. When you format it, this is one like kind of a little tiring task for SAS. Other software may give you better results quickly. So when you paste it, always paste like this, not paste like keep source. So if you keep source, it will see like those SAS format. So better paste option, right? So this formatting, if you use, then it will give you better pictures, and then you can work on it. You can use like separator, for example, 1000 separator, right? Format cells. Is it numbers? If it's a number, use the comma for 1000 separator. This one, if you want to minimize 0, maximize 0, Excel can do pretty much same thing. So what I did, I just copied and pasted every results, and then I just modified. I deleted those. We don't need to show these rows. Rather, 3 stars means highly significant. All are 3 stars. If it's less than 0.1, then 1 star. Right. You know the t-test. This is how we show. Less than 0.05, 2 star. Less than 0.01, 3 star. So now these are my raw results. From here, you can keep R square, and of course, year and industry dummy, you don't need to report. You will just report this. And even for this, you don't need to report both. T statistics are fine. Coefficient, too many digits. You can reduce it, 2 or 3 digits are fine. So what I'm gonna do, I edited all those Excel files, and now I'm gonna show you, I just show you the raw Excel table. Now I formatted the Excel tables, and you will see the Excel formatted. Formatting on Excel is good rather than formatting on Word documents. So once you copy, paste, or transfer the results from SAS to Excel, do every type of formatting on Excel. For example, percentage, this is my formatted Excel. Oh, I'm not sure sharing it. This is my formatted Excel table. This is my formatted Excel table. So now you can do all formatting. You please follow some journal, good, nice table, correlation matrix. This is the way. It's too many decimals. Maybe we need to reduce that. I could not. This is the standard way, right? And you can also do Darwin-Watson test or VIF multicollinearity. Then at the end, you have to put it all the tables in your paper, right? So what I did, I just copied, paste everything on Word doc. And this will be your final production. So if you see the Word document here, maybe the first data exercise, or maybe I have it somewhere. I'll upload that one. So the formatted table at the end will nicely be presented on your Word document. So sometimes you can also add some table heading. Table heading, table header. Okay, I am just uploading it now on Blackboard. Now it was on my desktop. I'm uploading it. So I uploaded the Word document, and you also need to produce this type of nice formatted table, but I didn't add everything here. Now this is my Word document, right? So every table, you should have some description. I didn't write all those. Table 1 sample distribution. This is my Word document, but you will write a little bit about the sample, a little bit about the Data sources, you will see all the papers, they do that. This is my industry-wide distribution. Descriptive statistics, this I should reduce more zeros, it's too many. Two or three digits are fine. And these are the regression results. So I put all regression in one table. So this is only financial variables. This is financial and CEO variables. And maybe I should add one more thing here, because the first two columns I didn't have year and industry fixed effect. So you can write it down here, year and industry fixed effects. Right. And then this time you will write all no. You don't have any year and industry fixed effect for the first two column, but the last one you will write no here, we'll write no here, we'll write yes, because after controlling year or industry, or you can make two rows. One is for industry fixed effect, another is for year fixed effect. Then the reader can compare. This is the robust model. Right. So our results is very good because even after all doing this, the result did not change much. So this will be your final output. So yeah, since we are not doing the paper now this semester, but I would expect you would have something for your dissertation. Any questions so far?